7 miles beneath the surface of the Pacific, in a place that has never once seen sunlight, a camera light flicks on and catches something drifting through the frame that, by every rule scientists had agreed on, simply shouldn't exist. Not a shadow, not a smear on the lens, a living, moving animal, whole and intact, in water where the pressure is strong enough to crush a submarine hull instantly. When the footage made it back to the surface, it didn't just surprise the researchers watching it. It forced them to quietly go back and question almost everything they thought they understood about the deepest place on Earth. To understand why that moment mattered so much, you have to start with the dive that made it possible. In 2019, an explorer and former naval officer named Victor Vescovo climbed into a submersible built specifically to survive the deepest point in any ocean on the planet, the Challenger Deep, the lowest known spot in the Mariana Trench. This wasn't a routine outing. Vescovo was sealed alone inside a small pressure sphere, descending nearly 7 miles through total darkness on a journey that took roughly 4 hours each way, with no rescue possible if anything went wrong. At that depth, the pressure exceeds 16,000 pounds per square inch, over 1,000 times the pressure at sea level. If the hull had failed, there would have been no injury to speak of. There would simply have been nothing left. Put the scale of that trench in perspective for a second. If you took Mount Everest, the tallest mountain on Earth, and dropped it into the Challenger Deep, its summit, the highest point on the planet's surface, would still sit under nearly a mile of water before you ever reach the ocean surface. Sunlight stops penetrating seawater at around 3,300 feet. The floor of this trench sits almost 10 times deeper than that. For the entire history of the planet, not a single photon of sunlight has ever touched the ground down there. It is, and has always been, absolute and total darkness. Given all of that, it's easy to see why, for most of scientific history, the working assumption was simple: nothing lives down there. In the 1800s, when researchers first tried dragging sampling equipment up from the deep ocean floor, they came back with little more than mud and cold sediment. No clear evidence of complex life. That absence became its own kind of proof, and scientists began referring to the deepest layer of the ocean as the Hadel zone, named after Hades, the underworld of Greek mythology. It wasn't a poetic flourish. It reflected a genuine, widely held belief that this was a lifeless, buried wasteland. That belief held even after the first humans reached the bottom. In 1960, two men, Don Walsh and Jacques Picard, rowed a submersible called the Trieste all the way down to Challenger Deep and reported seeing what looked like living creatures on the seafloor. But their equipment couldn't capture clear footage. Visibility was poor, and without solid proof, the scientific mainstream largely dismissed the sighting. For decades afterward, the assumption persisted almost unchanged. Whatever might technically survive down there would be rare, scattered, and barely clinging to existence. The turning point didn't come from a bold, new theory. It came from better technology quietly catching up to a question nobody had been able to properly answer. Starting in the 1970s, remotely operated vehicles and pressure-rated submersibles began reaching depths that had previously been unreachable, hauling back cameras and samples instead of just scoops of sediment. Then, in 1977, researchers exploring the deep seafloor found something that reshaped an entire field overnight. Hydrothermal vents, cracks in the ocean crust releasing superheated, mineral-rich water, and thriving around them. Dense communities of creatures living, feeding, and reproducing in total darkness. The explanation turned out to be chemosynthesis, a process by which certain organisms generate energy directly from chemical reactions instead of sunlight. It meant life didn't need the sun at all, and it should have been a serious warning sign about how much the ocean still had left to reveal. But even that discovery was happening at depths of around 20,000 to 25,000 feet, deep, but nowhere near the true floor of the trenches. The very deepest layer of the ocean remained essentially unexplored. That's the gap Vescovo's 2019 expedition, known as the 5 Deeps Expedition, was built to close. His submersible, the DSV limiting factor, was engineered specifically to survive repeated dives to full ocean depth, and it carried something none of its predecessors had: a high-definition camera system capable of capturing real detail in total blackness. Vescovo may dive after dive into Challenger Deep, each one a multi-hour round trip through crushing pressure, gathering hours of footage from a place almost no human eye had ever clearly seen. Watching that footage come in, back aboard the support ship, was Alan Jameson, a deep-sea biologist from Newcastle University who had spent much of his career studying the Hadel Zone specifically, the layer of ocean that most of the scientific establishment still treated as barely worth serious study. Jameson had built his career on the belief that this environment deserved real attention, often while facing skepticism from colleagues who saw the deep trenches as little more than a curiosity. When the footage started coming in, he wasn't watching for a spectacle. He was checking it against a career's worth of careful expectations about what should and shouldn't be down there. What came back did not match those expectations at all. The prevailing assumption had always been that even if something survived at these depths, it would be a rare, isolated organism, barely hanging on. Instead, the moment bait hit the water, the cameras captured a swarm, amphipods, small shrimp-like crustaceans, arriving in such overwhelming numbers that they stopped looking like individual animals and became something closer to a moving cloud, churning through the water toward the food. This wasn't a desperate straggler. It was a feeding frenzy, in a place that had been written off as essentially empty. Alongside them, cameras picked up sea cucumbers moving unhurried across the mud, working the sediment for scraps the same way their shallow water relatives do. There was nothing frantic or strained about their movement. No sign of animals barely surviving a hostile environment. They looked, if anything, completely at home. As researchers examined the footage more closely, they found not just abundance, but real diversity. Different types of amphipods, worms, isopods, and other organisms rarely, if ever, documented at that depth, each apparently occupying its own role in a working ecosystem. Scavengers, filter feeders, predators, all interconnected. A food web that organized and specialized doesn't appear overnight. Its existence implied that life hadn't simply stumbled into the trench and struggled to survive there. It had been settled in for a very long time. Even the pace of life down there defied expectation. Conventional biology assumed that in a place with so little available energy and such brutal cold, organisms would move slowly and conserve every calorie. The footage told a different story. The amphipods didn't drift toward food cautiously. They attacked it, competing aggressively, behaving like confident predators rather than creatures rationing their last reserves of energy. Fish moving through the same water swam with the same ease you'd expect from something cruising through a shallow, sunlit reef. Nothing about their behavior suggested survival mode. It looked, plainly, like an ordinary day at home. That raises an obvious question. How does anything survive intact under pressure strong enough to instantly destroy a submarine? The answer turns out to be less about brute resistance and more about balance. These animals are made almost entirely of water, and water barely compresses. So the pressure inside their bodies stays roughly matched to the crushing pressure outside. They aren't fighting the ocean. They're in equilibrium with it. At the cellular level, their proteins are structured to hold their shape under pressure that would deform ours. Their cell membranes contain specialized fats that stay flexible in conditions that would normally stiffen them, and their enzymes keep functioning efficiently in the cold and dark. None of this required some exotic, alien biology. It's the same basic biological machinery every living thing uses, adjusted in a handful of very precise ways. And then there was the animal that became the true symbol of the expedition, the Hadel snailfish. Roughly 8 to 10 inches long, with a soft, almost translucent, jelly-like body. It drifted through the camera lights, looking pale, delicate, and strangely serene. Nothing like the armored, monstrous creature you might expect to survive at these depths. By most assumptions about pressure and biology, an animal built this softly shouldn't have been able to hold together at all in a place capable of crushing steel. Instead, it moved through the water with the same unhurried ease as a fish in a calm, shallow tide pool. It wasn't the fearsome discovery people might have expected. It was something gentler and, in its own way, more unsettling. Proof that the boundary between livable and unlivable is far blurrier than anyone had assumed. It's worth being honest about where the footage's mystery actually ends, though. because this is exactly the kind of story that tends to get exaggerated. The cameras only ever illuminated a small pocket of water at a time, and beyond that narrow circle of light, the trench remained completely black. In some shots, the sediment on the seafloor appeared to shift as if something had recently passed through, without ever clearly entering the frame. There's no confirmed evidence of some undiscovered giant lurking just outside the light, and it would be dishonest to claim otherwise. What has genuinely changed is the old excuse scientists used to wave away odd sonar readings or unexplained movement, the assumption that nothing complex lived down there to cause them. That assumption no longer holds. The Mariana Trench itself stretches more than 1,500 miles along the seafloor, and the total footage collected so far amounts to a handful of narrow, well-lit snapshots scattered across an almost entirely unexplored expanse. Given that amphipods at these depths already grow noticeably larger than their shallow water relatives, it's a fair, open question, not a confirmed discovery. How much more remains genuinely undocumented down there? One puzzle from the footage remains stubbornly unresolved. What is actually feeding an ecosystem this large and this active, this far from any sunlight? The traditional explanation is marine snow, the slow, steady rain of dead organic material sinking down from the surface over days or weeks. It's a reasonable partial answer, but when researchers try to calculate how much organic material actually reaches the bottom, the numbers don't come close to supporting a community this dense and this energetic. Hydrothermal vent chemosynthesis might explain some of it, but vents haven't been documented throughout the entire trench, so it can't be the whole story either. It's possible there are energy sources or chemical processes at work that scientists simply haven't identified yet. It's also possible, and this is the explanation some researchers find most striking, that the Hadel ecosystem is simply far more efficient at recycling limited resources than anything in the sunlit world above, wasting almost nothing and sustaining more life on less energy than conventional biology would predict. Right now, there isn't a confirmed answer, just a thriving ecosystem, captured in crisp footage, that scientists still can't fully explain how it stays fed. Perhaps the most sobering discovery from the entire expedition wasn't biological at all. When Vescovo's submersible finally settled onto the floor of Challenger Deep, the cameras caught something else resting in the silt alongside the amphipods and sea cucumbers, a plastic bag, and a candy wrapper. In the most remote, least accessible place on the entire planet, human waste had already arrived first. It went further than that, too. When researchers examined the amphipods living at those depths, they found microplastics inside their bodies. Pollution generated at the surface hadn't just sunk to the bottom of the ocean. It had already worked its way into the tissue of animals that hadn't even been properly studied or documented yet. Step back and look at the full shape of what this expedition actually revealed. For generations, the deep ocean trenches were considered essentially dead, a lightless, barren desert with nothing worth studying. That assumption turned out to be wrong on almost every level. The Hadel Zone is crowded, active, and structured in ways nobody expected to find at that depth, home to a fragile-looking creature that shouldn't, by conventional logic, be able to survive there at all. Scientists still can't fully explain what's sustaining that ecosystem, and vast stretches of the trench remain completely unexplored, lit for only a handful of hours in all of human history. And in the middle of all that discovery, evidence of human carelessness had already beaten the scientists there. The footage from that expedition didn't just document a strange, resilient little fish drifting through the dark. It quietly dismantled a 2-century-old assumption about where the boundaries of life on Earth actually sit. And it left behind an uncomfortable, still open question. If an entire thriving ecosystem could stay completely hidden from us until 2019, in the one place we were most certain was empty, what else about our own planet have we simply gotten wrong?